So finding the inverse is the same for any function out there. Okay, it's the same for any function out there. The difference is when you're solving for y, some different things may happen depending on what type of function it is. So we're still going to begin by switching x and y. So if we're trying to find the inverse of f of x is equal to 4x squared, we begin by switching x and y. Then we would add or subtract. Do we have anything to add or subtract here? No, there's nothing being added or subtracted to the y, so we just skip that step. Next, we multiply or divide. So the y is being multiplied by 4. So we do the opposite, which is dividing by 4. So we have x over 4 is equal to y squared. Now, normally, when we were dealing with the linear functions, we were finished at this point. Y was by itself. Y is not by itself right now. Y is still being squared. So what is the opposite of squaring something? The square root. So we take the square root of both sides. When you take the square root of a fraction, you take the square root of the top and you take the square root of the bottom. And the square root of y squared is y. That was the whole point of taking the square root. Square root of something squared is just that thing. Okay, I'm going to go ahead and throw my inverse notation in there. So f inverse of x is equal to the square root of x. What is the square root of 4? 2. If you can simplify that, you go ahead and simplify. The square root of 4 is 2. If it were not a perfect square, if that were like 5 or 8 or something like that, you would leave it under that square root. Okay? But if it's a perfect square, go ahead and write it out or work it out. Okay? So really the only thing different is that when we're getting the variable by itself, it's squared, so then we have to do the opposite of squaring. Okay, so we started with a quadratic, we ended up with a square root. Let's do it the other way. Let's start with the square root and see what we end up with as its inverse. So switch x and y here. X is equal to the square root of y plus 1 minus 2. This time we do have something to add or subtract. We've got a minus 2 after that square root, so we add 2 to both sides because negative 2 plus 2 is 0. Now, we're trying to get y by itself. It's being, let's just call it, it's being protected by that square root. It's keeping it from being able to be isolated, so we've got to deal with the square root first. Okay, the opposite of taking the square root is squaring, so we need to square both sides. It's stuck inside that square root, so we got to get rid of the square root first before we can do anything with that plus 1. Okay, and then we can subtract the 1 from both sides. Now, we do not change what's inside that set of parentheses. Y is by itself, so I'm going to replace it with the inverse notation. Okay, you do not change, just like we couldn't take that 1 out of the square root, we're not supposed to subtract the 1 from the 2 because the 2 is inside those parentheses. So the minus 1 just gets stuck there on the end. Okay, so squared, square root, they're opposites, so they're inverses. If you start with the quadratic function, the inverse is a square root. You start with the square root, the inverse is a quadratic. Okay, pretty self-explanatory. Let's do 2 more just to make sure that we've got it, and then I will let y'all practice with this. H of x is equal to 9x squared. Let's switch x and y. X is equal to 9y squared. Nothing to add or subtract. So we go to multiply and divide. It's being multiplied by 9. The opposite of that is dividing by 9. So we have x over 9 is equal to y squared. Y is not by itself. It's being squared. So the opposite of squaring something is the square root. Square root of a fraction is the square root of the top over the square root of the bottom. The square root of y squared is y. Nine is a perfect square, so we can take its square root. So we've got the square root of x over 3. Now, it doesn't matter which side you write the inverse notation on, whether it's the left side or the right side. Technically, the way that I was working this out, it should be on the right side, but it really doesn't matter. Okay, we just traditionally put the notation first, and then we put the equation on the other side. So don't let that trip you up. Okay, let's do one more. Let's do this k of x right here. Any questions about the quadratic before we go on to another square root? Okay, switch x and y. That is the same every time. That never changes. So x is equal to the square root of y plus 4 plus 3. Add or subtract. You got to deal with the 3 first. You cannot take something out from under the square root. Okay, so we subtract the 3 from both sides. We got to get rid of the square root, so we square it. Square both sides. Squaring the square root cancels. And finally, to get y by itself, we subtract 4. Y is by itself, so I'm going to replace it with the inverse notation. Oops, that's a minus. Minus 3 squared minus 4. Okay. Once y'all get that written down, I'm going to show you the graphing side of it to confirm. Because this is most likely, I would think, going to be a multiple choice question. So if you have answer choices, you should be able to use those. So if our original is the square root of x, was it plus 4, plus 3? Okay, that was our original function. And then our inverse is x minus 3 squared minus 4. Now, let's look at the important parts. Okay, remember where the two curves intersect? Make it so you can see that a little bit better. Okay, where the two curves intersect, y equals x is supposed to go through that point as well, so that checks off. Now, when you look at it for the mirror image, it gets a little trippy because the parabola here does not completely mirror, okay? The reason for that is because if we had the bottom part of this square root function right here, okay, if I continued it so it looked like a parabola on its side, would that be a function? No, because it fails the vertical line test, right? So if we had this bottom part right here, what I'm saying is, I had a negative in front of that. If I had the positive and negative square root to complete that graph, okay, this square root would no longer be a function because it would fail the vertical line test. But when I put it there, you do see that it is now a complete mirror image, okay? So you don't worry about that part. We have to restrict the square root function to just the positive square root so that it is actually a function, so that it passes the vertical line test. So just kind of ignore the left side of the parabola, okay? Ignore the left side of the parabola when you're trying to check this. Now, here's what I mean by you can check your answer choice. What if you had accidentally said that that was supposed to be a plus 4 instead of a minus 4? Okay, obviously where these intersect, y equals x does not go through that point, and they're definitely not mirror images across that line. Okay, so it's a tool to check to see if you got your signs right, if you got everything in the right place. Does that make sense?